Hi everyone, my name is Harry Goldstein. I'm a postdoc at the University of Maryland College Park, and this is, I'm presenting Tyche, a tool for making sense of property-based testing effectiveness. Now, I'm a big believer that if you want people to do things that they don't like to do, you should give them better tools to do that thing. And the story I'm going to tell you today is about software testing. This is how programmers ensure that their code does what they think it does, but they generally don't consider it to be a fun part of the process. Even worse, I'm not just talking about standard example-based unit testing here, where software engineers write input-output examples to make sure they haven't made glaring mistakes. I'm talking about more rigorous approaches to testing, like random testing, where the user has to put in even more effort in the hopes of getting even more confidence that their software is correct. Now, these approaches to random testing are really valuable. They've been used to find bugs in Dropbox's file system and Volvo's car software. And in a study we did last year, we found that random testing does indeed increase software engineers' confidence in their software. However, what we also found is that they find it to be a difficult and time-consuming part of the process, especially when it comes to evaluating whether their random testing was effective. Now, why is this such a challenge? Well, if you think about the picture I just showed you, they're using a random data generator to exercise their code. And in order to know if they've done a good job, they might have to look at pages and pages of random inputs to understand if they're happy with what actually happened during testing. This isn't just tedious, but it's error-prone. Developers we spoke with pointed out that they actually shipped bugs into production because they hadn't properly evaluated that their testing was doing what they thought it did. And so this brings me back to where I started. If you want people, in this case software developers, to do things that they don't like to do, like carefully evaluate their testing, you should give them better tools to do that thing. And that's why I'm presenting Tyche here today. In the rest of this talk, I'll go over some background, talk about a design exploration study that we did, then I'll show you the tool itself, talk about some evaluation, and then a little bit of future work. So first on to the background. The kind of random testing that I'm talking about today is called property-based testing, and it's the most commonly used in a library called Hypothesis in Python, although you can find it in pretty much every mainstream programming language. The way this works is a programmer writes an executable specification of their code. So for example, this is a property that checks something about binary search trees, and there's two parts of this property. First, assumptions about the random data that is going to be used to test this property. These say what it means for data to be valid to test with. And then you have assertions which say something about the system under test. This all goes together in a big system with a random data generator, and if you get lots and lots of successes, you can be confident that your software is correct. If you get failures, you found a counterexample, and maybe you have something to fix in your code. The problem here can come in with these assumptions. If you're not careful about how you generate data, you can fail a bunch of assumptions and waste a bunch of time generating invalid data. For example, in the case of these binary search trees, if you generate valid trees just a small percentage of the time, most of that testing time is actually being wasted. What's worse, if your generator produces uninteresting valid data, so for example, trees that are way too small, that can also be bad for testing. It can lead to sort of false sense of security. So the idea here is to change the way that programmers interact with the property-based testing process to make it easier to evaluate testing effectiveness. We designed our tool Tyche through a design exploration. We started with a prototype tool based on our previous study, and then we had 5 participants who are maintainers or experienced users of Hypothesis help us to iterate on the design. Through this process, we came up with 5 design principles that informed Tyche's design. The first is visual feedback. Developers did not want to see these walls and what happened? There we go. Okay. Visual feedback. Developers didn't want to see. Yeah. Developers didn't want to see walls and walls, a wall of text with lots of data inputs. They instead wanted charts and graphs that helped them to understand what was going on during the testing process. Workflow integration was really important. They didn't want to have to go far for this information, and so we put it right alongside their code in their editor. Customizability is key because no two testing situations are the same, so developers need to be able to express what is interesting or important about their particular testing scenario. Details on demand means that rather than show developers all of the detail we have at once, we should show them higher-level summaries and let them drill in when they're curious about the lower-level data. And finally, standardization is important because we didn't want this to just work for hypothesis in Python. We wanted this to work for property-based testing frameworks kind of across, and other random testing frameworks too. So now I'm going to give you a little bit of a demonstration of Tyche. It's just a slideware demo. Unfortunately, I didn't have time to switch over to the actual thing. Suppose I'm a developer. I've written a property in Python, and I want to test it. So I'm going to go down to my terminal, and I'm going to run PyTest. It's going to tell me that one test passed. That's not very helpful. There were actually hundreds of tests being run through this property, and I don't know what happened with any of them. So I'm going to rerun with a new command line flag that enables Tyche. Tyche will appear on the side of my editor and allow me to ask more interesting questions about what happened during testing. So for example, if we focus on this part of the screen, we can see this mosaic chart, which helps me to answer questions about the validity of the data that I use to test my property. In this case, we see this isn't so good. About half of the data that we generated ended up being thrown away. If we scroll down in the interface, we can see other features of our data, including distributional things like the sizes of the things that we generated. In this case as well, the sizes are way too small to be useful for testing. So if we zoom out, we can actually change the way data is being generated. This is just normal hypothesis stuff. You can switch out the data generator if you do that over here. And now, if we look back at the mosaic chart, we can see we've made some significant improvement. Most of the data we generated is valid. What's more, if we scroll down, we can see that the distribution of sizes got much more interesting too, which means that we're doing a better job covering the system under test. A little bit on the architecture of this. So Tyche is a React app that is shown through a Visual Studio Code extension, but you can also access it through the web if you don't use VS Code. And property-based testing frameworks can output a standardized JSON format, which we take in, which means that this can be used with lots and lots of different frameworks. As of now, we have Tyche implemented for 5 different languages and 5 different property-based testing frameworks. But in my experience, it takes about an afternoon to implement for a new language. So if you have a property-based testing or other random testing framework you like, go ahead and implement it. We did a little evaluation to make sure that this was actually helping developers. So we wanted to make sure that it helped developers to evaluate the generators, different data generators. So we had 40 participants recruited from social media and at our university. And what we did was we showed each developer 3 different generators, either through Tyche or through a control interface. And we asked them to rank the relative bug-finding power that they expected from each of these generators. Behind the scenes, we knew which of these generators found the most, the next most, and the least bugs, so we had ground truth. When we measured the number of mistakes that developers made using Tyche versus using control, we found that in many cases, developers were much better at determining the correct order of generators with Tyche than with the control. In particular, in our 4 tasks, developers were statistically significantly better in 3 of the 4 tasks. We also have some evidence that Tyche is useful beyond just this formal evaluation. We've actually helped to close 4 different bug issues in Hypothesis itself because of the feedback that Tyche provides. So during our design exploration, developers would look at the data, say, this looks weird, and it turned out not to be a bug in their test setup, but actually in the framework itself. And so this gives me more confidence that like having this out there is giving people access to data that they weren't looking at before. Just a quick note on future work is that I imagine Tyche as being part of a kind of broader integrated development environment for property-based testing, which will help beginners get started and experts be productive with property-based testing. Tyche is available as a VS Code extension on the extension store as well as on the web. These are my lovely collaborators, and also I'm on the academic job market right now, so if you're hiring in HCI, SE, or PL, please get in touch. Thank you.
Hi, my name is Tony Tang from Singapore Management University. Really interesting. I was never a really good software engineer, and so I was definitely one of those people that never understood much about testing. Recently, I started coding again with GitHub Copilot, which seemed really great, except for every once in a while it creates problems. So I was kind of thinking like, oh, this is kind of neat. But I guess the question I suppose is, what is, like, I saw your explanation of what property-based testing was. I was kind of curious, like, is there something special about property-based testing? Are there other kinds of testing that I haven't thought about? Like, so I'm not sure what that question is, but something along those lines?
Yeah, I mean, the testing literature is broad, and it's further complicated by the fact that there's multiple names for each different approach to testing. But I think certainly I see this fitting into the world of, say, AI-generated code as a way to, like you said, help to catch some of the mistakes that these AI code agents are making. And I think property-based testing is one great tool for that. I think standard unit testing is also really important. As long as you're thinking carefully about the correctness of your software, I think that's a really good first step.
Yen, Virginia Tech. Great talk. I had a question regarding the process of how participants updating their code once they find its unsatisfying outcomes. Can you just walk us through some of the processes once they find out, oh, I don't want this kind of distribution of my output? How do you do updating their testing set?
Sure. So one thing you can absolutely do is sort of swap out the data generator or write a new data generator. There's lots of research into how to do that well, and also tools for automating that. In our study, we isolated just the interface part, just the sort of does the interface tell the developer that there is something to change. And so we didn't make like a lot of formal observations about what developers do sort of after they see the output from Tyche. But I'd love to talk offline if you want to discuss that more. There's a lot there.
Great. Yeah. Just to follow up on that, could you imagine the tool to help the users to almost like guiding them what to change on the code, given the output, and also, let's say if they actually want the output to distribute in this way or having this kind of visualization? Was there?
Yes, we hope to be able to do that soon. I mean, one thing I would really like to do is to be able to sort of drag the bars in the bar chart up and down and have that sort of feedback into the generators. This is technically very difficult, but we've made some progress on it recently. So I have all sorts of ideas for like bidirectional feedback. It's just getting the technologies to work well is currently in progress.
Awesome. Thank you so much.
Thank you.